In this video, we'll learn how wireless local area networks, or as they're more commonly referred to, Wi-Fi networks, are used to provide wireless network access in the home and in the workplace. So let's think about a conference room meeting, something that happens all the time in the workspace. And back when I started my career, everybody would come to these meetings with a pen and a paper and probably a cup of coffee. And that's all you would need to bring to your conference room meeting. But these days, when people show up for a conference room meeting, they're not bringing pens, they're not bringing papers, they're bringing their devices. They can take their devices wherever they want in the workplace. They're not connected to the wall. They're not connected to a physical network switch in a data center. So many things have changed with the availability of wireless local area networks, or wireless LAN, within the corporate workspace. And now they're even prevalent in home networks as well. So the vast majority of computers in a home network are not connected to an Ethernet cable anymore. They all connect using wireless networking, using Wi-Fi. So let's start with one of the most basic concepts of wireless networking. We have different frequencies available, right? We have 2.4 gigahertz and we have 5 gigahertz. You may have noticed this at work. You may have noticed this in your home networks. When you're connecting to Wi-Fi, you can pick which frequency you want to use. And there's benefits and drawbacks to either of these options. So let's start with 2.4 gigahertz because this has been around a whole lot longer than 5G. With 2.4 gigahertz, the range is typically somewhere around 150 feet or 45 meters indoors. That's the indoor range of 2.4 gigahertz. The outdoor range is something more like 500 feet or 90 meters outdoors. So 2.4 gigahertz isn't quite as fast as 5G, but the range is long. But if you're connecting with the 5 gigahertz frequency or 5G, your speeds are going to be faster, but your range is going to suffer. The range is only going to be about 50 feet or 15 meters indoors. So 5G is faster. 2.4 gigahertz has a longer range. So what is the speed difference between these two types of networks? Well, with a 2.4 gigahertz network, about 150 megabits per second is kind of a normal maximum speed. Versus 5G, the maximum speed is much, much higher. Now, just go into this with an understanding that although the maximum speed of 5G is much, much faster, let's say that you're just using the internet, right? Maybe you're at home watching Netflix and you have to choose, do I want 2.4 gigahertz or 5G? Well, how fast is your internet connection, right? Because just think about where the bottleneck truly is. If you're not getting 150 megabits per second through the internet, then it doesn't really matter which one of these networks you connect to. But if you're using a high-speed local area network and you need maximum speed, 5G is going to give you that within that local network. So either in a home or a corporate network, regardless, we're going to have something called a Wi-Fi access point, or AP. This is the actual physical device that your computers and your other wireless devices are going to connect to. And the access point itself is going to be connected to some other network physically. It's going to actually have a wired connection to some other network. So let's just assume that this is a home network, right? Here's your Wi-Fi access point. This is what your laptop, your tablet, all those things are going to connect to this Wi-Fi access point. And let's assume that in your home network, you have an internet connection, right? So here is the router that comes from whoever your internet service provider is, right? And the access point is going to connect up to that router, right? So your little computer here, let's assume you're using a laptop. Here's my laptop. The laptop connects to the Wi-Fi access point wirelessly. So this is a wireless connection. And then once I establish a connection to that, I can connect through that Wi-Fi access point to my router from my internet service provider, and from there I can get to the internet. So the access point is the device that my wireless systems actually connect to. So when we're talking about the difference between 2.4 gigahertz versus 5 gigahertz, we're specifically talking about the connection between the wireless device and the access point. Once the traffic actually heads upstream towards the upstream network, 5G and 2.4G don't make any difference after that point. So now let's take this from a typical home network, and instead let's talk more about a corporate network. And again, within a corporate network, you're still going to have the same types of systems, right? You're still going to have access points. You're still going to have routers. But normally, in a corporate network, it probably won't be quite this simple. Now, one of the things that you'll typically see in a corporate network is we will often have multiple access points, right? So each access point maybe serves a certain part of the building. Maybe there's an access point for a large conference room in a hotel, and nothing else uses that access point. Maybe you've got an access point in your lobby, or one per floor, or one per department. But regardless, you're going to have multiple access points, and different users will connect to different access points. And all of those access points will typically be connected to a switch. So let's add a switch to our diagram here. And so now we've got all of these access points connected up to this switch. And as such, they can all communicate with each other, right? They can all communicate with anything that's connected to this switch. And also, the switch is connected to my router. So if I have to get traffic to and from the internet, we're connected upstream to a router. Now, as we start to scale out our environment and have multiple access points, there's certain things that we need to consider. Number one, the management of all of these access points is going to potentially start to become a little bit more challenging. And we may potentially want to introduce something called a wireless LAN controller. And the objective of the wireless LAN controller is to allow us to manage all of these access points from a single centralized point, right? That's the goal of the wireless LAN controller, is to give us a centralized point to control all of our Wi-Fi access points. Now, there's also other considerations to think about here. We can make it possible to roam from one access point to another. We can enable mobility in this case. So, for example, let's say that I've got my user here and they are utilizing their laptop in the conference room, and then the meeting ends and they go to their office. Well, this particular access point is used for the conference room, but maybe this one way down here is used for their office. So when they walk away from the conference room and go sit down in their office, do I want them to have to reconnect to Wi-Fi? Ideally, no. I would like to enable mobility so that as they move from one room to another, one location to another, they can just connect to a different access point in that different location without losing their network connection, without having to reconnect. So in this particular situation, the wireless LAN controller is really the brains behind the operation, and all of these Wi-Fi access points are more lightweight, and we can move from one Wi-Fi access point to another as we walk through the building without having to reconnect. This is what is called an extended service area, an extended service area that spans multiple Wi-Fi access points. And so, for example, if you've ever gone on your laptop and you've tried to connect to a Wi-Fi network, you see something called an SSID exposed. The SSID stands for Service Set Identifier. So basically, you'll choose an SSID, and you basically think of the SSID as your network's name. Well, in this case, the SSID is actually the wireless LAN controller, and the wireless LAN controller enables you to connect using any of these access points. So let's think about this in terms of a concept that we're already comfortable with, an Ethernet local area network, right? Well, now I can have multiple devices connected to my wireless LAN. So for example, we'll call this other device laptop 2. We could have different users with different devices. They are connecting to the same SSID, but they are actually connecting potentially to different access points. But all of that traffic can be moved through the physical switch, so everything on my wireless LAN can communicate with one another. If that traffic is destined for the internet, the MAC table of the switch will be used to forward that traffic to a router, and from there, the traffic can go out and reach the internet. So in many ways, a wireless LAN is similar to a wired Ethernet network in the way that it actually functions. The biggest difference is layer 1. Right? With layer 1 in a physical wired network, you've got to have that Ethernet cable. You've got to have that category 5 or category 6 Ethernet cable. Versus in a wireless LAN, you're not tethered to the wall. You can move around and you can stay connected to that SSID even as you move through the building and connect to different access points.